Hi, in this video we will go through functions evaluation and function compositions as well as inverse of functions. Consider the function f, which is defined from a to b with the equation y is equal to f of x. Furthermore, consider a value a from the domain of the function. In order to evaluate the value of the function when x is equal to a, we substitute the value of a instead of x in the function. For example, if we have our function f of x is equal to x squared plus x minus 1 and want to evaluate this function at 2, minus 2 and 0, what we do is we substitute these values instead of x in the equation of the function. Let's start with 2. If x is 2, that means we substitute x with 2 anywhere we have x. F of x is equal to x squared plus x minus 1. Therefore, f of 2 is 2 squared plus 2 minus 1. 2 squared is 4. 2 minus 1 is 1. 4 plus 1 is 5. Therefore, the value of the function when x is equal to 2 is 5. For x is equal to minus 2, the same way we substitute x with minus 2. Therefore, f of minus 2 is equal to minus 2 all square. Remember that you have to put this bracket here in order to include minus in the power, then plus again the bracket minus 2 minus 1. Minus 2 square, remember that this is minus 2 times minus 2 is 4, plus times minus is minus minus 2 minus 1. Minus 2 and minus 1 is minus 3 plus 4 is 1. Hence, the value of the function when x is equal to minus 2 is 1. To find the value of the function when x is 0, we simply substitute x with 0. Hence, f of 0 is equal to 0 squared plus 0 minus 1. These two parts are 0. Then we are left off with minus 1. Hence, the value of the function when x is equal to 0 is minus 1. Before defining the composition of two functions, consider a function which is defined from a to b, let's call it f, and another function which is defined from b to c, let's call it g. If you have a closer look to these two functions, we see that the domain of f is a and the range of f is b. For the function g, the domain is b and the range is c. What we can see is the domain of g and the range of f, they are the same set. This is a crucial point when we find the composition of g and f. If we have two such functions such that the range of this function and the domain of this function are the same set, we can define the composition of g and f, which is defined from a to c through b. In other words, g or f, which is the composition of g and f, is a function which is defined from a to c, such that g or f of x is equal to g of f of x. In other words, f of x, which is the value of the function f, is playing the role of independent variable for the function g. Consider functions f of x is equal to x minus 1 and g of x is equal to minus x plus 1. Later on, we will see that the domain and range of these two functions are all real numbers. Therefore, the condition that the range of one of the functions should be the same as the domain of the other function is satisfied here. In order to find the composition of g and f or g or f of x, what we do is we consider g of x, which is minus x plus 1, and in this function we substitute x with f of x. Here we replace x with f of x. We do the same thing on the right hand side. Minus is minus. Instead of x, we have f of x plus 1. Plus 1 coming from here. Then we have minus sign, bracket. Why we need bracket? Because this minus sign is being multiplied with all terms inside. Instead of f of x, now we put the value of f of x, which is 2x minus 1. Now we multiply this minus with both terms inside, we get minus 2x, minus and minus is plus 1, we have plus 1 from there. As a result, we have minus 2x, 1 and 1 is 2. As a result, the composition of G and F is minus 2x plus 2, which is defined from the set of real numbers to the set of real numbers. In addition to GOAF, we can also find FOG, which is f of g of x, the composition of f and f, which is f of x, and the composition of g and g, which is g of x. Utilizing the composition of two functions, we can check whether the two functions are inverse of one another or not. Consider f, which is defined from a to b, and another function g, which is defined from b to a. These two functions are inverse of one another if the composition of f and g is equal to the composition of g and f, and both of them x. Hence, in order for the two functions to be inverse of one another, we have two conditions. First of all, the domain of one of the function is the range of the other function, and the range of the one of the function is the domain of the other function. That means, for example, f is defined from a to b, g is defined from b to a. Second, the composition of both functions f and g and f should be x. If these two conditions are satisfied, the two functions are inverse and being shown as follows. F is equal to g minus 1 of x, which means that f is the inverse of g, and g is equal to f minus 1 of x. In other words, g is the inverse of f. Consider f of x to be x plus 1 and g of x to be x minus 1. Remember that the domain and the range of both of these functions are the set of real numbers. Therefore, this condition of the domain of one of the functions should be the range of the other one is satisfied. Furthermore, in order to check whether these two functions are inverse or not, we have to check this further condition here. In other words, we have to check whether the composition of f and g and f are the same. To that end, first we find the composition of g and f, which is g of f of x, where we substitute in the definition of g instead of x, f of x, which is x plus 1. X plus 1 minus 1, x plus 1 minus 1, minus 1 and plus 1 is 0, we get x. But still we are not done. Still we have to check the composition of f and g. The composition of f and g is f of g of x. What we do is, in the definition of f of x, we substitute or we replace this x with g of x. Hence we get, instead of x, x minus 1, which is g of x, plus 1, which is equal to x minus 1 plus 1 minus 1 plus 1 is 0 is equal to x. Therefore, f of g and g of f are x, both of them. Hence, the two functions are inverse. In other words, f is the inverse of g and g is the inverse of f.